Allumage et décollage.
Hello and welcome to this live webcast brought to you by Arianespace for our 6th mission of the year and our return to flight for our light launcher Vega. A very special mission tonight, no less than 53 satellites on board Vega for this very first rideshare mission for Arianespace. With me on set here in Paris, Beatrice Romero. She is a Program Director for Arianespace. Thank you for being with us tonight.
Thank you and good evening.
And here to my right, Alexandre Dallonneau. He is System Manager for Vega and Vega-C, and Alexandre will be with us throughout the evening to take us through all the milestones of this mission. Thanks for being with us.
Thank you too, and good evening.
And for the French speakers among you, you can follow a live and real-time translation thanks to our interpreters Marc Fermin and Alexandre Carayon. Over now to Kourou, where our launcher is waiting on the pad with our passengers safe and sound under the fairing. And straight over to Mission Control, where our CEO, Stéphane Israël, is heading up the flight desk. Good evening, Stéphane. How are things going in Kourou, and can you please introduce us to your team there?
Yes, so we are now in the Jupiter Control Center and we are in the flight cell. So I have with me my colleagues. So we have Bruno Gérard, who is at the head of our establishment here in Guiana. We have Giulio Renzo, who is the CEO of Avio, our prime contractor for this launch. And we have Pierre Tissier, who is our Deputy Chief Technology Officer.
And so, as we were saying, a very first rideshare mission here for Arianespace. Can you tell us more about this new offer?
Yes, it's very important because tonight is a real premiere. For the first time in Europe, we will have a mission which will embark 53 satellites in the same launcher with Vega. And this is a new offer which is dedicated to this emerging segment of the market, the small satellite between a few grams to 200 kilos.
So a very impressive offer which will be giving access to space to a whole new range of customers. The launch, unfortunately, was postponed several times. Can you take us through these delays?
Yes, so we have had to reschedule the launch because in March we have had the pandemic and everyone has understood that we have to take special measures, and so we have had to slow down a little bit our activities. In June we were ready to come back to the launch pad with our customers and with the launcher, but unfortunately due to negative high altitude winds it was not possible to launch. But what I can tell you tonight is that the weather is with us, and as you can see on the control screen, the weather is green.
That is fantastic news. Good to hear it from you, Stéphane. Tonight also marks, of course, Vega's return to flight, as we were saying.
Yes, so it was a little more than 1 year ago. We have had an anomaly with Vega after an impressive tempo of successes. It is things which can happen in our business. We have perfectly understood with all our partners, with ESA, with Avio, the root cause of the anomaly. And tonight we are ready for the launch.
Well, thank you very much, Stéphane, for joining us. I know this is a very busy time for you. We are some 10 minutes to lift off, so we're going to let you get back to your teams and back to work. Thank you for taking time out, and we'll be back with you just after our second separation. That's in about an hour's time. So thank you very much for joining us, and we'll be back speaking to you in about an hour's time.
Thank you, Elise.
Thank you, Stéphane. And Beatrice, as we were saying, it's been a very eventful year here. Tonight we're launching VV16, and you're already working on the next flight, aren't you?
Yes, that's correct. I'm working already on VV17. And for VV16, we are really very proud to be here today because we have overcome all kinds of adversities. As Stefan just explained, the first launch attempt was in March, and the campaign was put on hold just 10 days before the launch due to the lockdown that was imposed by the pandemic of the COVID. And then, despite all these difficulties that we had during the sanitary crisis, we resumed the launch campaign for a new attempt in June. And at that time, the weather was not on our side, definitely. And even yesterday, we have another unexpected weather event. So here we are now for VV16 and also preparing the next Vega launch for hopefully in November.
So as always in space, looking to the future, and back to tonight's mission here. So as I was saying to you, Alexandre is going to be taking us through all the milestones. Can you please tell us about the key moments to look out for, please?
Of course, Liz. So, following the liftoff from CSG, the first solid booster stage, PAT, starts the mission with a flight duration less than 2 minutes. The second and the third stages, Zefiro-23 and Zefiro-9, will increase the launcher velocity with the help of their own propellant consumption and their respective separations. After 6 minutes and 30 seconds, the launcher reaches hypersonic velocity around Mach 11 at 200 km altitude. The Avum upper stage will ignite its engine for the first time, operating for about 8 minutes, targeting orbit conditions. After a first long ballistic phase, a reignition occurs for about 1.5 minutes, prior to releasing the first 7 satellites at 515 km. At this stage, Liz, we will end the webcast, but of course, you can follow on social media the rest of the mission. Customer sequence will end by releasing the 46 CubeSat 15 km higher after 2 short Avum boost durations and a second long ballistic phase. Then, for the total mission customer duration, it will be for this mission 1 hour and 45 minutes.
Thank you very much for all these explanations, Alex. So we'll be back speaking to you very soon. Beatrice, you work alongside the customers on a lot of these missions. When it comes, there's a very precise campaign for each mission. And of course, all preparations take place at the Kourou Space Center, the CSG, which is actually a very large area, the size of New York City. More than 700 kilometers square. So can you maybe take us for a bird's eye oversight of the Vega facilities, the facilities that are being used here for this particular mission?
Yeah, sure. So here we have the payload processing facilities. These are the buildings where the satellites are prepared for launch. This is the aerial view of the S5 building. That is one of the most advanced payload facilities in the world. It allows us having several launch campaigns in parallel, as there are 2 halls for the standalone operations and 2 other buildings, those blocks that we can see on the left side of the screen, for the hazardous operations like the propellant fillings. Other facilities for Vega. And now we are going to see as well the Vega Launch Control Center. So this is the place where the launch vehicle operations are managed. And it's a common building for the Ariane and the Vega launches.
It's very near to the launch pad, isn't it?
Yeah, it's very close to the launch pad. And now we are going to have the view of the launch pad, very nice view. And the launch vehicle is directly integrated inside, so in this pad, and the payload composite joins the launcher when it's encapsulated. And all those operations are performed inside the mobile gantry that we can see there. The gantry is not there now because it has been rolled out about 3 hours before liftoff. This is the entrance of the launch base with the Jupiter 2, that is the Mission Control Center. It's situated just on the right side at the entrance. And we will see more images of the inside of this building because all our management is there. And Galileo, which is the tracking station, the first one that will receive the first telemetries, the first part of the telemetry of the launcher, is located in La Montagne de Père, about 20 kilometers from the launch base.
Thank you very much, Beatrice. So here we have an oversight of what is going on there in Kourou. I was telling you, Alexandra will be taking us through the key moments of the mission, but you will also be hearing another voice throughout the evening, and that is the voice of the Range Operations Manager in Mission Control. His name is Raymond Boyce. He is called, in French, he's called the DDO, and he is the person whose voice will be calling out all these major milestones. We're actually coming up to one right now, Alexandra, aren't we? At 4 minutes, we should hear the start of what they call the synchronized sequence.
Attention pour la séquence finale lanceur. Top à 0-4 minutes.
So what does that mean, Alexandre?
Yes, so it's an important milestone, Liz. All of system representative of the range, the launcher and upper part are green, and we can continue until the start of the automated sequence 30 seconds before liftoff. In other words, it's a medical examination before hiring, and as you can see, we are healthy and ready to carry out the job.
So our Vega is ready to go.
Yes.
Right, okay. So another piece that you can't miss in Mission Control, if we go back to the pictures of the Jupiter Control Center, is the giant screen that towers over the teams there, the operational teams. And it is called the status panel. We'll be going over to it shortly. And as Alexandra was saying, all the markers are green on that status panel. What does it reflect?
So yes, you can see on the screen as a global status panel. We have all the subsystems coming from the launch base, giving their status towards the Mission Control Center. On one hand, you have the range representative of the safety criteria, logistic and ground mains. On the other hand, the launcher helps with electrical and mechanical checks. Finally, the upper part checks, including SSMS dispenser and satellite status. Liz, as a traffic light, it is a green. You can go. It is red. You should stop.
Absolutely. And so you will be able, of course, to take us through these moments thanks to your expertise, but also thanks to the information you'll be receiving through your earpiece. Can you tell us more about that?
Yes, I'm connected directly to our colleague in Kourou CVI by this earpiece.
It's the same information the DDO is receiving, is that right?
Exactly, exactly. So this team received all Vega flight parameters in Galileo, as mentioned by Beatrice. They have 3 panels focused on propulsion parameters, guidance, navigation, and control activations, and trajectory. Head of CVI will synthesize their respective and numerous feedbacks in real time, transmitting information to DDO.
And so this information, that there are many, many parameters, hundreds of parameters being collected, and of course they can't all be analyzed in real time, so the proper deep analysis will start as of the day after the launch, as far as I understand.
Tomorrow.
Right.
Yes.
And this information will be used for the next launches.
Yes, you will receive all this experience from this flight, and you will apply all positive feedback to improve the next flight.
Of course. And so it looks like we're coming up to another milestone. The DDO's voice calling out the 1 minute mark, I believe.
Top à 0-1 minute.
So there we go.
Yes, so the flags are green. Weather status is good. We are getting closer to the automated sequence, and I'm keeping my finger crossed.
Well, we're all crossing our fingers here in Paris. We're going to wish everyone good luck and sit back and enjoy the launch. We'll be back with you shortly.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage P80. Allumage P80, décollage. SSMS for flight.
What a sight, Alexandre. You've been working on these Vega launches for years.
Yes.
How does it feel? You're 15.
Very exciting and moving at the same time. So really, it's a Vega rebirth.
Because apart from the first one, you have always been there.
Yes, yes, from the second flight. So you can admire the liftoff on the launcher acceleration made on the first stage burn, PAT, with an average thrust of 230 tons for a launcher total mass roughly twice less. This is what gives Vega this particular feeling of acceleration.
Very impressive, Beatrice. I mean, you are used to seeing these takeoffs. It's something else, isn't it?
I used to see those takeoffs, but always inside the Jupiter, so never outside. But it's really very impressive to see anyway in the screen.
So, Alexandre, take us through a lot of. We were just listening to the DDO announcing a lot of milestones taking place in very quick succession. Please take us through it.
Yes, now it's the tail off of the first stage. It's confirmed by the DDO. And now the separation of the first stage is confirmed. So approximately the ignition of the second one, named VV16, it is confirmed now.
And the information from the launcher, we can still see the sky. It's an amazing sky we have tonight. We're very, very lucky. The information from our launch is being picked up by the first ground station along its path, as we were saying earlier, Beatrice, the station of Galileo in Kourou. In mission control, of course, everyone is following what is happening very, very closely. And you can follow on your screen here to the right. You can follow the altitude, distance, and speed of our launcher, its trajectory on that yellow line to the right of your screen there. So everything nominal, as they're telling us in mission control. So back in Jupiter, key figures working on this mission, of course, representing the European Space Agency. We have Charlotte Besco. She is head of the ESA Kourou office, and she is the first woman in this position. Alongside Charlotte, we have Daniel Neuenschwander. He is Director of Space and Transportation. And representing the CSG, we have Marianne Claire. She took over as head of the CSG just 9 months ago, and it is also the first time a woman takes on this position. Coming up to another milestone, Alexandre.
Second stage separation is confirmed. A few seconds of ballistic. And you will see in the coming few seconds the ignition confirmed. 5 seconds later, separation of the fairing. And you can admire with this 3D simulation the SSMS structure with all satellites around.
And we are now in outer space. We have yes, we have reached the place where our passengers are no longer under any threat, and therefore we can get rid of the fairing.
Yeah.
So our first separation scheduled in just over 35 minutes. Earlier, we spoke to Fabrizio Fabiani. He is program director on this mission. He has been working very hard over the past months. Believe me, it has been an unprecedented challenge. This is what he had to tell us.
On this mission, we have 7 microsats on the upper part of the SSMS carrying structure and 46 nanosatellites hosted in the lower part called Hexagon. Let me spend some words about the 7 microsats. First, the satellite to be separated is under contract and procured by rideshare provider Spaceflight Inc. The second one is Nemo HD, that is the first Slovenian satellite for Earth observation, designed and manufactured in collaboration between SpaceSI and Spaceflight Laboratory from the Institute for Arianespace Studies of the University of Toronto, and will be operated by SpaceSI. The third one is UPMSat-2, an in-orbit demonstration satellite with the goal to improve education, research, industrial spin-off and international cooperation. The project is led by Polytechnical University of Madrid. The fourth is GRGSat-C1, the first commercial satellite for GRGSat Inc. of Montreal, developed by SFL on Nemo platform, whose mission is to measure greenhouse gases emissions. After that, on the main deck, we have ISAIL, the first commercial satellite developed in partnership with the European Space Agency, involving Desert Earth as mission operator and LuxSpace as prime contractor. NewSat-6, an Earth observation satellite built and operated by Satellogic, and ION SCV Lucas, a spacecraft designed and built by Deorbit, able to transport several satellites into space and deploy them individually into precise orbital slots.
And that was Fabrizio Fabiani. He is mission director on this flight VV16. Alexandre here to tell us all about this mission tonight. We're coming up to one of the key moments.
The confirmation of the first stage separation. That's good. So we had 3 successive significant acceleration flight phases. We are now at Mach 11 above atmospheric threshold at 200 kilometer altitude. And this Zeta 9 will have a fall down in ocean.
And as we were saying, Vega's path takes it northwards. All along its journey, it is, of course, being followed by these ground stations. We mentioned Galileo. All the information is being sent to the CVI, the real-time visual control. Tell us a little bit more about, because you've spent time in the CVI, haven't you, for your job?
Yes, I was in front of the trajectory panels, so I have a dedicated dedicated for them as they are working on this special flight. So CVI received by telemetry or flight parameters from all the ground tracking stations used for this mission. That is mean French Guiana, as you mentioned, Bermuda Island, Canada, South Korea, and Australia. So you can say it's a wonderful international contribution under CNES responsibility.
Absolutely, and we heard a confirmation that we were acquired by Bermuda just over 40 seconds ago. And there we have Marianne Claire, the director of the CSG I was telling you about earlier. Alexandre, I think we're about to, did we hear confirmation from the DDO, the first AVUM ignition?
It is confirmed now.
There we go.
So this boost is mandatory to target orbit conditions defined by a perigee altitude greater than 120 kilometers.
And what happens during this AVUM flight phase?
So during this flight phase, Canadian Saint-Hubert telemetry ground station is acquiring data. So you have an overlap between Bermuda and Canadian station. And this first boost is targeting intermediate orbit parameters. When achieved, the stage will cut off.
Thank you very much, Alexandre. I don't know what we'd do without you. So a reminder, this very first rideshare mission for Arianespace on board Vega, 53 passengers on board, 3 separations. Let's hear more from our program director, Fabrizio Fabiani in Kourou.
What we are looking at is the motion of the satellite separation that is going to happen in a few moments. On this mission, we will have 3 separations. First one involves the 4 microsat which are on the towers. The second batch involves the 3 microsat on the deck. And the last one, delayed by about 10 minutes and on a higher orbit, will involve the separation of all the 46 nanosatellites which are hosted in the canisters integrated onto the Hexa module. The canisters on this mission have several sizes and come from several manufacturers like ISIS, Tyvak and Astrophane. The main feature of the canister is to protect the satellites during the launch and to eject the satellite into space when the separation command from the launcher reaches the opening mechanism that allows the satellite to get out. On this mission, we have satellites from 0.25 unit up to 6 unit, One unit is a cube having the dimension of a Rubik cube. In particular, we have 38 CubeSats for commercial customers with different missions, ranging from Earth observation, Internet of Things, and in-orbit demonstration, and 8 for institutional customers with mainly educational and scientific purposes. The separation sequence for such kind of missions is quite complicated because it has to assure no collision between CubeSats. We have globally 21 customers for all over the world, and in particular from US, Canada, Thailand, South America, and many from Europe. I'm very proud to have worked with all of them side by side for about 2 years. It was a great experience to exchange with so many persons from different nationalities, cultures, and backgrounds. I personally learned much from all of them. It was a long and challenging journey, receiving a so huge amount of data from all the customers, putting them together, doing the mission analysis and making available the key data to the right person at the right time. It was a great teamwork. I'm so grateful to everybody for that. Thank you.
So 53 passengers on board our launch tonight, and among them a few from North America. We're joined live now by Stella Guiana, live from Washington, D.C. Stella Guiana is Arianespace's VP for Sales and Marketing. Good morning, good evening, Stella. Good morning for us, good evening for you. Thank you for joining us.
Hi, Liz. So excited to be here.
We were talking about the North American market. What are the prospects for the SSMS on the US market?
Yes, so out of the 53 satellites, a lot of them are from the US. This is a market, the small satellite market has been growing tremendously, about 10 times since 2010. We consider small satellites between 1 kilogram to 400 kilogram, which equates about 300 satellites a year. So it's a significant market for us. And with the help of the European Space Agency and the L3 program, we have been able to develop some carriers that can actually help us meet the demands of this market. So very exciting.
And tell us, what is Arianespace's answer to that? What are your differentiators?
So we are actually very uniquely positioned to meet this market needs. Arianespace is a family of launch vehicles that complement each other. So that gives us the capacity to basically offer launch services for any satellites, any shape or mass of satellites to any orbit at any time. Today, we're launching to a LEO orbit, but we have other, we're launching constellations to MEO. We are launching to geostationary orbits. We're having a lunar program rideshare mission coming up on Ariane 6. So all kinds of flexibility in orbits. And also our new vehicles, Vega C and Ariane 6, will give us the flexibility or the capability to perform several boosts of the launch. And that will allow us to give smart deployment schemes for customers for rideshare missions and for constellations. We're also providing some financial schemes to new entrants in the market. That's thanks to BPI and the European Investment Bank. Lots of flexibility and a very reliable launch service.
And so, as you were mentioning, Vega C to look forward to in 2021.
Il reste moins de 2 minutes de propulsion de la Vega.
Yes, we're very excited. There's a lot happening on Vega, and for the small satellite market and the rideshare possibilities, we actually have coming up 2 missions on the next 6 months that will allow us to put rideshare missions for CubeSats. So it's a great opportunity. We have an equatorial launch rideshare mission coming up as well. Obviously Vega C, and also on Ariane 6 coming up as the new launcher as well.
And in a few seconds,
exciting.
Yeah, you might have a message for your partners tonight in a few seconds, Stella.
Absolutely. Thank you so much. We know that every satellite mission has tons of people behind it, and their hearts and hopes and everything goes with a day like today, the launch day. So we want to say thank you so much to our customers for the trust they put in us, and for the Vega team that has worked so hard and has giving us so much passion and drive through the campaign. Thank you so much.
Thank you very much for joining us. That was Stella Guillen live from Washington, D.C. Thanks, Stella.
Thank you.
And back here in the studio in Paris, Beatrice has left us shortly in order to be able to respect social distancing rules. And Luce Fabregat, Arianespace Executive VP, has joined us. Thank you very much for being with us, Luce.
Thank you, Belize. Good morning.
Good morning, indeed. You have returned from Kourou quite recently.
Yes, 2 weeks ago, in fact, after the launch, the successful launch of Ariane 5.
Congratulations.
Thank you, and I'm very pleased to be, thanks to all the teams, in fact, and I'm very pleased to be here with you, almost at home, to follow this launch, this Vega launch today.
Well, thank you very much. And while we were speaking, Alexandre, sorry, but another milestone, the AVUM extinction occurred.
De la VUM.
You can hear now it's the first AVUM boost cutoff. So we will start a slow maneuver to start a long ballistic phase with a dedicated barbecue mode.
Mm-hmm. Well, thank you very much for this information. And we're now going to be going to some replay pictures of tonight's launch. You can never watch it too many times. And this will be an opportunity for me to ask our two guests here who've been around for a while and who've seen quite a few launches. Have you actually seen many of them with your very own eyes? Because you're probably most of the time sitting in mission control or somewhere else.
Exactly. Unfortunately, I could see only twice launches. It's a gift when you are in training. Yes, it's impressive and forever in mind. But on the other side, the land campaign job does not allow to rejoice in such a spectacle as you are dedicated to your work during the flight.
Absolutely. So, same question goes to you, Luce. I mean, you've been with Arianespace for some time.
For 15 years now. Mm-hmm. And as for Alex, I've seen most of the launches from inside. Mm-hmm. I think I have been lucky to see around 10 launches from outside, Kourou and Baikonur.
And Baikonur as well.
Baikonur as well. And I must say that from outside, it's really even more impressive than from inside. Even though from the mission center, you can hear the sound, the noise of the liftoff, and you can feel the vibrations. But for outside, it's much more magical, and that's. I believe I will never be blasé about this spectacle.
Absolutely, it is true. I have experienced it myself, and even within the Jupiter Control Center, it is unbelievable how you sense the vibrations. Absolutely.
I'm a little envious about people outside in French Guiana today.
Yes, they are lucky to be there. Tonight's mission marks Vega's return to flight after more than a year, doesn't it, Luce?
Yes, we were lucky, in fact, with the beginning of Vega. We had 14 successes in a row, which is a record for a new launcher in the world. And then last year, in July, we had this failure of Vega, the first failure of Vega. But since then, we have had to perform huge job, huge work with ESA and Avio, our partners. And now we are ready, and we have seen that the launch is performing perfectly with this Z23 that was the issue that had the anomaly last year.
Thank you very much, Luce. And we're going to be going over to this short video of our Chief Technical Officer, Roland Lagier, on Vega's return to flight.
Today's return-to-flight mission is the result of a major effort of all the Vega community to overcome the failure of VV16 mission in July last year, which occurred after an impressive series of 14 successful missions. Immediately after the flight, the European Space Agency and Arianespace set up an independent inquiry commission co-chaired by ESA Inspector General Tony Tolker-Nielsen and myself as the Arianespace Chief Technical Officer. This commission was composed of independent experts from Avio, ESA, CNES, and ASI space agencies, along with representatives of the Italian and French Ministries of Defense. We worked during all the summer analyzing all available telemetry data from the flight, with special focus on the propelled phase of the Zefiro 23 second stage, during which the anomaly occurred. At the completion of this extensive and thorough process, we defined one possible and most probable root cause. We identify a combination of weaknesses in the design, the manufacturing, and the control processes of the internal thermal protection of the Zefiro 23 casing forward dome. The conclusion of this comprehensive activity were delivered at the beginning of November 2019, with 20 recommendations, out of which 14 were deemed mandatory and to be implemented before today's return to flight mission. In complement to the corrections of the anomalies that triggered the flight VV16 failure, additional actions were defined, enabling to reinforce the robustness of the design and the production flow. All these recommendations were accepted by the ESA Qualification Authority, which took the lead for managing their implementation in close cooperation with Avio, the Vega prime contractor. Many thanks to everyone who contributed to this effort that will make the Vega launch vehicle more robust and the teams in charge of Vega launch system even stronger and more united. Thank you for your attention, and go Vega!
That was Arianespace's CTO, Roland Lagier. Alexandre, you said earlier it's Vega's rebirth tonight.
Yes, it's a very important flight. Yes, it's a rebirth after VV15 anomaly and 11 months of intense investigations. Vega had, as mentioned by Luz, 14 success in a row since its first flight in 2012. But similar to all launchers that persist on the market, this painful step is inevitable. This is an integral part of the launch system life. So anyway, we learn from this failure, as mentioned by Roland, making us stronger than ever.
Absolutely, and as Stéphane Israël was saying, it is also our very first rideshare mission.
Yes, it's for its rebirth, in fact, as was said by Alex, Vega is blazing the trail with this new rideshare mission, which is very important for providing new services to new customers, institutional customers, answer institutional needs, universities, which is also very important, and it was mentioned by Beatrice also before, and private commercial new entrants to this market that becomes affordable thanks to this solution, SSMS solution.
Thank you very much for that, Luz. We're going to be going back to mission control shortly because, of course, Vega's prime contractor is, of course, Italy's Avio, and we're going to be speaking to Avio's CEO, Giulio Ranzo. He's going to be joining us from Mission Control, where they're all very concentrated on the mission tonight, as we're coming up in just over 17 minutes to the first separation. Good evening, Mr. Ranzo. Thank you for joining us. Can you hear me?
Good evening to you. Thank you for inviting me.
Good evening. So, of course, as we've been saying throughout the webcast, it has been quite a year, hasn't it?
Yes, it has been a very challenging year. I think we started in March with the expected return to flight. We were ready to go. But as you have probably noticed, we've been stopped by the evidence of the pandemic. And so we were deferred to launch in June. But unfortunately, we hit again an exceptional condition of a bad weather condition. And so we were pushed back to fly in early September. But here we are, and now we're orbital at this moment.
And of course, it's also a first, it's a proof of concept flight. Can you tell us more about this new service?
Yes, I think it's a first-timer for Europe. It's the very first time we arrange a so-called rideshare mission. We're going to be taking 53 satellites to space all at once with a very sophisticated technology that Avio has put in place under the umbrella of an ESA program. To deliver these satellites to different parts in space, different places, with the help of very sophisticated technology. So we're very happy for this to open up the new market for small satellites for Europe.
And as we were talking about with Stella Guienne from Washington, early 2021 is also going to see something new with Vega C.
Yes, indeed. This is the project we've been working on for the last 4 years. It's a new version of Vega, more powerful, with 2.3 tons capacity in low Earth orbit as compared to 1.5 tons in low Earth orbit, which Vega has at the moment. So this will provide customers with more cost competitiveness, so it'll be increasingly more attractive for customers, and we will perfect certain technologies to the highest end.
So it's a very big night tonight for you and for your partners.
Yes, of course. I will take this opportunity to thank the whole partnership of the European stakeholders. We've been working closely with the launch service provider Arianespace and with the French space agency CNES, as well as with the European Space Agency over the last few very challenging months. And if it was not for our partnership, we wouldn't be here today. So I think partnership is the name of the game tonight.
Well, thank you very much for taking the time to speak with us. Avio CEO, Mr. Giulio Ranzo, thank you very much. And we're actually going to stay in mission control. We're going to speak as well to Marino Franito. He is Arianespace's he also is part of the Arianespace family. So Marino is going to tell us a little bit more about this very special SSMS offer, because of course Vega is the smallest, the youngest of the Arianespace family, and Arianespace looks back at 40 years of innovation, of which the SSMS is the very latest. So Marino, are you there? Can you hear us in mission control? Marino Franito? Marino, hello.
Yeah, hi Liz.
Thank you very much for taking the time to be with us. Thank you. So tell us more about this
we're
this
very
new
happy
service.
to be here tonight. We're very happy that we have a liftoff. Yeah, so first of all, I have to say that Vega is a launcher which has been conceived to serve the small satellite market, and it has performed a series of very exotic missions since its introduction. And even if let's say that it has mostly served small satellites and sun-synchronous orbits, and SSMS is a new kind of exotic mission, but especially it's our new service to structure the offer for the small satellite industry. So, as you all know, Arianespace has structured the commercial market, has been the first launch service provider in the world for the commercial satellite market. Now our ambition is also to structure the small satellite market and to serve the small satellite industry with a very reliable, affordable and regular service to space.
And how do you achieve such an affordable service?
Yeah, so our solution was based on streamlining, let's say, the integration of small satellites. We have performed for the very first time integration of satellites in Europe, in Czech Republic. We have simplified the contractual clauses for our customers, and we have reduced a lot the integration time to the launch vehicle. Now, it's clear that I say all this, but I also have to thank our customers for being with us tonight, and for having been with us for this very long time in which we have suffered the delays and problems. So we want to start from this point, from tonight, for this mission tonight, to establish this very regular service and affordable and reliable service for our customers.
Marino, good to see you. Could you
over
just...
to Luce.
Lucy speaking, yes. Could you just maybe say a word about the European Commission, which is an important customer
nice to see you
tonight?
as well. Yeah, it's not only an important customer, I mean, it's also a very important partner, because we have to thank the European Commission, the European Union for being behind us. We probably we wouldn't be here tonight with SSMS if the European Commission and the European Union had not backed us on this very ambitious program. And I think it's not only helping Arianespace to achieve this mission tonight, but it's simulating the European new space economy that we want to create and to make a very established and very well organized new space economy.
Marino, thank you very much for taking time out from your very busy schedule to speak to us. I realize that we're coming up to about 10 minutes before the first separation, so I'll let you get back to your team and back to work, and good luck with everything this evening. Thank you very much for being with us, Marino Franito.
Thank you, and let's cross our fingers for a bit longer. Bye.
Bye-bye, and we'll be back with you shortly in mission control. So we're now less than 10 minutes away from our first separation. This moment has been a long time coming, hasn't it, Luce?
Yes, right. And
so how do you feel so close to the goal?
That's really an exciting moment. And usually, when I am in the mission center, as Marino and Stéphane are today, when we are with the CNES teams and the customer teams, you can feel in these last minutes before the announcement of the separation an atmosphere of sharp and heavy concentration, and the center is getting more and more silent, expecting this announcement. So it's really a crucial time in the launch, for sure.
Yeah, and as you were saying to me just before we went live, a time when everything goes quite silent.
That's right. Yeah,
absolutely.
More and more silent. Yeah.
Luce, you're going to be leaving us for a short while, but you'll be back. In the meantime, Alexandre, could you please take us through the main events of the mission so far and what we can look forward to?
Yes, and I will record the main phase for morning spectators.
For those who are joining us.
Yes.
Who missed their alarm clock.
During the first phases of flight, the solid booster stages PAT, Zefiro-23 and Zefiro-9 were tracked by the telemetry ground station Galileo over a duration of 6 minutes and 30 seconds. Due to safety aspects, these 3 stages will re-enter in the seas. The last stage, integrating a liquid engine and named AVUM, reached a transfer orbit after first boost duration of 8 minutes. These boosts were tracked by Bermude and Canadian Saint-Hubert ground station. In order to make the first SS orbit circular, shorter second boost of 1.5 minutes will occur under South Korean Jeju station visibility after a long intermittent ballistic phase of 20 minutes. Once the targeted orbit reached, the 7 passengers on top of SSMS deck will be released. For the second part of the mission, a short third AVUM boost will occur under Australian Lunasia station in order to start the target's 530 km SSO. And after 1 Earth rotation, a fourth AVUM boost will circularize the CubeSat injection orbit. Then, the separation sequence will be tracked by Bermuda ground station telemetry. Finally, the mission will end by a 5th AVUM boost and will re-enter in the ocean. The total Vega mission will last less than 2 hours.
Thank you so much, Alexandre, for all those details. And we are welcoming back here on set in Paris. Beatrice, thank you for being back with us.
Yes, to you.
And I think we're also back in touch with our launcher, Alex.
Yes, we will be quite at the end of this first long ballistic phase. Jeju is have to acquire, because I'm waiting the confirmation.
We're waiting for confirmation by the DDO.
Exactly.
Right, okay.
But I can say just before, so have to acquire the launch vehicle and the second AVUM boost. And this boost have to occur in a couple of minutes to complete the first injection of it. So I'm waiting this confirmation now.
And the data, as you were saying, is then being transmitted as always. During the non-visibility phase, it's stocked, and then as soon as we're back in visibility, all the data is transferred to your colleagues at the CVI.
Just before.
Waiting for confirmation in your earpiece?
Yes, from CVI I have confirmation that Jeju is acquired, the launcher.
Acquisition.
Yes, we have a confirmation done from the DDO. So yeah, just to answer to your question, all data is recorded during this ballistic phase, and it will be downloaded under this South Korean ground station.
The South Korean ground station, which gave us a big fright last night, didn't it?
Oh yes, yes, linked to the typhoon, but fortunately today we launch with a better situation.
Fantastic. And so as for the lower 46 passengers, they were integrated in Europe for the very first time, in the Czech Republic, to be precise. So we're going to meet the team behind this company specialized in the launch services. But I think Beatrice wanted to tell us, first of all, about in a few seconds, about an innovation that you had to think up.
Yes, because we need to think that when the campaign was resumed end of May,
we have very short time.
We have just 14 days of quarantine imposed in French Guiana, and also
we'll have to come back.
Okay. I will let
after the video.
After the video.
Thank you.
Sure.
5 years ago, we started with this amazing project called SSMS, Multiple Satellite Launch System for Vega launch. To make access to space more affordable, we went even further. It is for the very first time when secondary payload is integrated directly on the spacecraft in Europe. For this purpose, we opened dedicated laboratory, custom bonded area, where we can handle also non-EU customers. We provide this service through SAP Launch Services, company from our group.
Satellites customers are asked to deliver their satellites here in Brno 8 weeks prior to the launch. After 1 week of standalone operation, the populated deployer are installed on the hexagonal module of the SSMS. So 5 weeks prior to the launch, the assembly is picked up and is transferred by truck to the Orly airport. By a commercial plane, the assembly is transferred to French Guiana for the final operation and for the assembly on the launcher structure.
So, Beatrice, as we were saying just before the video, you were telling me how you were forced to become very creative.
Yeah, as I was saying, in end of May we had a quarantine in French Guiana, and also some of the customers were not able to get the launch space because of the travel restrictions. So you're right, we needed to be innovative and to create the way to perform the remaining operations on their behalf. And for that, we established a high-quality process to strictly follow all the procedures that the customers provided, doing rehearsals, doing some trainings, and also for the first time using the smart glasses. And those glasses allow customers to remotely follow all the operations, to provide instructions, drive those operations.
You can see them right there on the screen behind Beatrice, behind me. Yeah.
And also to assess the flight worthiness of the satellites before encapsulation.
Absolutely. So, yeah, necessity is the mother of invention.
Yes,
in unprecedented times, you find unprecedented.
We found a way to do it.
Answers, absolutely. Alexandre, we're about to come up to the separation. Can you please tell us how the separation occurs?
Yes, the first satellite will be released within a constant time sequence. All the separation relative velocities were defined by tuning each separation device. Thanks to the time and velocity factors, we assure safe separation for each customer. That means for this kind of rideshare mission, a complex separation strategy has to be put in place due to the number of satellites and the request to avoid any collision. And now I have the confirmation of the second AVUM boost ignition, and this, the duration of this boost will be 1.5 minutes. I recall the aim of this second boost is to circularize the final orbit injection.
So a lot of passengers tonight are from the biggest, which weighs 138 kilos, I see here, about the size of a small refrigerator, down to our nano satellites in lower position, which are no larger than a smartphone. Is that right?
Yes, you are perfectly right. On SSMS PoC, the smaller spacecraft is roughly the size of this smartphone. So, and imagine, if you stack 12 together, you can deliver a small constellation with only one separation order inside the same deployer track.
But what can you do with such a small satellite?
It's important to have in mind that if I would like to put this cell phone in orbit, with this 150-gram satellite has camera, GPS, and accelerometers covered by a long-life battery. With this small device, I get a satellite with main function observation, localization, attitude diagnosis.
Absolutely fascinating. Thank you for those explanations.
And I have a confirmation of the second heaven boost cutoff.
So what does this mean?
That means that it's a green light to separate first batch of satellites. So the separation sequence will start.
So as you can imagine, in mission control right now, all eyes are on the computers. Satellite separation coming up in less than 20 seconds. And as Luz was telling us earlier when she was here, a moment of great silence and concentration in mission control.
Séparation Athéna.
Separation are confirmed, the first true one on longitudinal direction and the first transversally.
And there we go, we see some signs. Of course, this is the first of 3 separations. Nevertheless, it has been a long time coming, and we can see the expressions of joy there in mission control.
If you don't mind, I would like to add something.
Please, Beatrice.
Because I'm personally touched by one of those separations, one of those satellites that has been developed and manufactured by the students of the University in Madrid, where I made my engineering studies. So if I'm here today working in the space business, it's thanks to one of those projects. I would like to highlight the importance that the small satellite projects in the university has for creating new space engineers, and also to thank all the entities that provide the necessary support to make that happen. So thank you very much to all those actors.
That is a very touching testimony. Thank you very much for being here with us tonight, Beatrice. You're going to be leaving us now, and we're going to be welcoming back Luz Fabregat. But first, over to this film from the European Space Agency.
Thanks to SSMS, or Small Spacecraft Mission Service, more than 50 satellites will be launched at once. This new dispenser has been developed by ESA and Avio and manufactured by Saab Aerospace in the Czech Republic. The European Commission is contributing to this proof-of-concept flight. Until now, the launch opportunities for the smallest class of satellites were limited, as they typically had to make use of large satellite launches' spare capacity to get a piggyback ride to orbit. But the SSMS takes a different approach.
The Small Spacecraft Mission Service allows to perform dedicated launches, specific for and tailored for small spacecrafts. In this way, on one side, there is the reduction of the launch cost, and on the other side, there is a maximization of the launch opportunities.
The SSMS is composed of modular parts, such as a hexagon module, rods, towers and columns. These can be assembled in various configurations, depending on the requirements of the satellites that will be launched, offering a great versatility and the ability to accommodate any combination of customers. The payload integration for the lower part of the system is done in Europe by the SSMS manufacturer, reducing cost and effort for small satellite companies. The top-level satellites are added at Europe's spaceport in Kourou. Once in orbit, the satellites will be deployed in a coordinated fashion, after which the Vega upper stage carrying SSMS will de-orbit. Later on, this new dispenser will also be used for Vega C. offering an extra 800 kilograms of capacity and an enlarged volume within a wider launcher fairing, at the same cost as Vega today, flying even more passengers per individual SSMS launch, with a significant cost reduction per kilo. An important development for Europe in an evolving launcher market.
Today we are trying to cover all the market needs that we have concerning launching satellites into low Earth orbit. This SSMS service is today compatible both with the Vega as well as with the upgraded version of Vega called Vega C. In reality, we are today designing a generalized version of the SSMS for Vega C, so that we will be able to launch any kind of combination of small spacecrafts in the future. And we are using the opportunity that we have with the Vega to have a proof of this concept.
For this maiden flight, SSMS will deliver all its passengers into the same sun-synchronous orbit at an altitude of 550 kilometers. But in the future, Vega could deliver its payloads on separate orbits. With SSMS, Europe is making its lightweight Vega launcher more versatile, thus providing new launch opportunities for small satellite manufacturers and operators at competitive costs.
And joining us live now from Darmstadt in Germany, ESA Director General Jan Werner. Jan Werner, Herr Werner, hello. Can you hear me?
Hello.
Thank you very much for joining us at this very early hour. So as we were saying, the European Space Agency funded the SSMS hardware development and contributed with the European Union to the funding of this proof of concept flight. So what does this project represent for ESA?
So this project for us is, of course, a very important one, because it shows also flexibility, agility, and also cost reduction. So it's, as you mentioned, this very nice acronym SSMS, which means Small Spacecraft Mission Service, is a very special case because we have 53 satellites on board and coming from different sources, from different countries. So 13 countries, 21 customers. This is, of course, already something special, but also for us it's very important that it is returned to flight after the mishap of VV16. It's a very important step for us, and also for the future of using these, also this launcher for many purposes.
And the flight comes, of course, amid unprecedented times. How did ESA deal with the effects of the coronavirus lockdown?
Yeah, the coronavirus lockdown was, of course, a shock for us. We started in late February this year to observe the situation and to think about consequences for us. And then we went in total teleworking very early in March, meaning all people, we sent home all people. That was possible for ESA because we have teleworking already as a normal action in our daily life. But of course, to send all people at the same time home was difficult. We could not, and we should not send all, because, for instance, Kourou, we cannot go back from the launch site. We had a similar situation with the Satellite Operations Center in Darmstadt, where we still needed people. The satellites were flying even with the virus. And also some of the test laboratories were continuing. But we reduced people dramatically, and I can say they performed very well. We could even accelerate our payments to industry, which was very important at these times. But now we are back, and this is good.
As you're saying, we're back. Luce Fabregat is here with us on set. I think you wanted to ask Jan Werner a question about
the launcher, maybe, yes, Jan, because it's also the return back to flight of Vega. So what does it mean for ESA, according to you?
Yeah, you see, first of all, for me personally, it's really a great relief that we saw this marvelous launch, because you can understand if a launch does not work, it's already the Director General who is guilty. That's very sure. If it's success, many people are there and celebrating it, that's good. But if something happens, then of course I get immediately very bad reactions. And therefore, it's for me personally also a big satisfaction that all people work together with Avio and also with ESA and Arianespace to really make this flight a success, and therefore I'm really happy about it.
Thank you very much for being with us tonight or this morning, Jan Werner, Director General of ESA. Thank you for joining us. That was Jan Werner live from Darmstadt in Germany. As we were saying, unique EU-ESA cooperation. So we're going to go straight over to this interview with Pierre Delceau from the European Commission.
The European Commission considers that this experience is extremely important because actually we want to use this experience to launch new satellites and small satellites and to test small satellites in orbit. And from that point of view, developing this kind of technology is fundamental for us because we believe that in the future this technology will continue to grow in Europe, but also elsewhere in the world. And we want Europe to remain competitive and to be part of these developments. So from that point of view, the European Commission is very keen, actually, to have this kind of testing in orbit with the new Vega launch. And of course, for that, the cooperation with ESA is fundamental for us because we really believe that it's important that all of us work together to develop this type of technologies in Europe. In this particular case, the Commission has been quite ambitious because we financed more than 11 million euro for this launch. And actually, what we want to test is actually the possibility to have small satellites being launched and being tested in orbit. We really believe that small satellites are a key factor and key players in the future of a space sector in Europe and elsewhere also, and we want Europe to play a very important role in this sector. If I knew about the future, you know, but I can tell you at least that the current Horizon 2020 program will be replaced by a program which is called Horizon Europe, which is not yet completely final because we still don't know the amount of money which will be available for this program, for this research program. But what I know is that space will continue to be financed through this research program, Horizon Europe. And of course, in this context, as the European Commission, we will continue to work with our key player, ESA. And certainly, we are now working on how to establish our future relationship with ESA in a global context, not only, of course, for research, but also for the flagship programs like Galileo and Copernicus.
And we're coming up to our second separation of the 3 remaining passengers, the small satellites on the main deck. Can you tell us more, Alexandre?
So, yes, we will release three satellites. Both satellites will be released simultaneously, and the last one only 80 milliseconds later. Linked to the strategy, as I mentioned before, of the relative velocity and timeline sequence. I have a confirmation that we are under New Norcia ground station telemetry.
So New Norcia in Australia.
Yes.
Absolutely. So this is the last one, the last station.
Yes, indeed, we were obliged to wait this acquisition to perform the next satellite release, so the 3 that I mentioned before, because all active phases, including separation, have to be tracked by a ground station under French law. So, you know, all launcher providers launching from French Guiana have to be able to give and justify launcher data during these critical phases, which are the propulsion separation 1.
And thanks to, I would like to add a thanks to CNES teams for this. For their involvement on these important topics for us, from mission design, in fact, up to the flight monitoring as is today, and of course the operations in French Guiana.
And here we have it.
Oh,
you should see Alexandre.
Yes, the mission is not finished, but I'm very happy with these 7 microsatellite separations.
So that's it. The second separation are 3 remaining passengers on the main deck. Here in mission control, behind the masks, happy faces all around. I can tell you so much. Yes, smiles loose.
Smiles behind the masks. We can imagine. Yes, of course. This is not the end of the mission, as was said by Alex, of course, but already long life to our first 7 babies already separated. Mm-hmm. They have lived together for a few months. On ground and during the flight right now.
Longer than usual.
Longer than was scheduled, yes. Of course. But each of them is now starting it's an individual journey, and we wish each of them a long life in space.
And you were going to tell us about one of those satellites in particular, Alexandra.
Yes, there is another one, proof of concept inside this flight. It's like a Russian doll. It's already mentioned.
A Russian doll? What do you mean by that?
With you know,
the dolls, and
the dolls,
yes, the smaller one
from
inside.
Moscow,
yes,
with a lot of piece inside, and it's quite the same philo, because this satellite is loaded with a dozen of CubeSats inside. It's a demonstrator, and the aim of this new concept is, in fine, to be able to move satellites to different orbits and altitudes independently of the launcher life. It's the future.
Absolutely, it's the future. Well, Luce, 46 satellites separating next.
In less than 3 minutes.
3 minutes.
It will be a record for Arianespace.
Has that been done before?
No. It will be the first time for Arianespace.
First time for Arianespace. So a lot of firsts tonight.
You're right, yes.
Some mission this is tonight. We'll shortly be going back to Kourou to hear from Arianespace CEO Stéphane Israël after this second successful separation. Arianespace has been launching from French Guiana, from the Guiana Space Center, for 40 years. So let's watch this film marking Arianespace's 40th anniversary.
Ariane 1, the first launch vehicle designed in Europe, lifted off for the first time in December 1979. It drew on France's preliminary work on the Diamond rocket and was designed from the outset for geostationary launches. This made it perfect for the growing communications satellite market. Europe quickly capitalized on this opportunity in 1980 by founding Arianespace, the first commercial space transport company. And this new launch service provider would rapidly carve out its own market segment. The first member of the Ariane family logged 11 launches between 1979 and 1986 for both government and commercial customers. For instance, Ariane 1 was chosen to launch Giotto, the European Space Agency's first deep space mission, which flew by Halley's Comet. With this success under its belt, ESA quickly developed Ariane 2 and 3. These were more powerful, in line with the growing size of telecom satellites. Arianespace would carry out 17 missions with these two launches, from 1982 to 1989. Ariane 3 added the ability to perform dual launches, sending 2 satellites at a time towards geostationary orbit, and this technique would quickly become the hallmark of Arianespace. At the end of the 1980s came Ariane 4, a launcher that used the same basic design as its predecessors, but was even more capable. In particular, it was modular with 6 different versions, and it was a spectacular market success. In 15 years, this new rocket would carry out 116 launches for customers from around the world. The launch base in Kourou, French Guiana, was a beehive of activity throughout the 90s, regularly reaching a rate of 1 launch a month. Because of this rocket's capabilities, Arianespace captured fully half of the global market for commercial launches. Ariane 4 was retired in 2003, passing the baton to the newest family member, Ariane 5. This heavy launcher featured a different design, but brilliantly carried on the tradition of its older brother. Once again, the idea was to boost its power to handle increasingly hefty telecom satellites, while also maintaining the strategy of dual launches into geostationary orbit. At the same time, Arianespace decided to expand its family by offering launches on the storied Soyuz rocket from the Guiana Space Center. This service started in 2011 and would notably support the deployments of Europe's own satellite navigation system, Galileo. Arianespace also teamed up with the Russian Space Agency to offer Soyuz launches from the Baikonur Cosmodrome, operated by Starsem, a joint European-Russian company. During the first decade of the new millennium, ESA chose the solution to launch its Mars Express and Venus Express spacecraft. Then in 2012, Arianespace introduced a new light launch vehicle, Vega. Developed by Avio at the initiative of Italy, Vega clearly showed Europe's expertise in solid propulsion. Despite its small size, Vega has already carried some very prestigious payloads. In 2015, for instance, it lofted ESA's IXV re-entry demonstrator. That same year, it launched LISA Pathfinder, a proof-of-concept demonstrator that will enable ESA to design and launch a huge space-based laser interferometer to detect gravitational waves. With this trio of launchers, Arianespace now had a complete family capable of handling all types of missions, whether into low, medium, or geostationary orbit. Ariane 5 has now been in operation for 24 years, more than half of Arianespace's lifetime. It has carried out over 100 missions, including some very prestigious ones for the European Space Agency. For instance, it launched the XMM Newton X-ray Observatory, sent Rosetta to study the comet 67P-TG, propelled Bepi Colombo on its way to Mercury, and also sent ATV pressurized cargo vessels to the International Space Station. While it's now reaching end of life, Ariane 5 has yet to say its final word, since it will shortly be orbiting the eagerly awaited James Webb Space Telescope. To date, Soyuz has carried out 23 missions from the Guiana Space Center and Vega 15. As it hits 40, Arianespace must now tackle new challenges. Competition has grown fiercer over the last decade, while market pressure has driven down prices and the pace of innovation continues to accelerate. Satellites are changing as well, in line with new uses. Communication requirements have exploded, meaning that current terrestrial networks will have to operate alongside low-orbit constellations capable of providing anywhere, anytime internet access at affordable prices. High-resolution Earth observation satellites are set to revolutionize our understanding of the environment. Research, agriculture, maritime traffic management, and even finance could well benefit from imaging that's refreshed several times a day, using special satellite constellations. In other words, there's no lack of launch opportunities. Spaceborne objects will be increasingly diversified to address a wide range of needs. Not only space probes and telescopes to help us better understand the universe, but also programs designed to make life better on Earth, with space applications that benefit everybody. The Arianespace family is evolving to address these changes, thanks to teamwork with our space agency partners. A new version of our light launcher, Vega C, is ready to enter service. The prime contractor, Avio, has boosted performance and fitted it with a larger fairing, so it can continue to support the government market as well as the booming smallsat segment. Europe's light launcher will also feature a new modular satellite dispenser, allowing it to carry several dozen smallsats on a single flight. Moving to the heavyweights, Ariane 6 will soon be in operation. The new Arianespace family flagship will combine the power of Ariane 5 with the modular design of Ariane 4. Offered in two basic versions, it will be highly versatile. Ariane 6 could also address the smallsat market, for example, on missions shared with geostationary satellites. Its new restartable upper stage will make Ariane 6 especially effective in the deployment of mega constellations. What's more, its capabilities will allow Europe to reach brand new destinations, such as the Moon, or launch interplanetary missions. Of course, dual launches into geostationary orbit are still on the agenda. To ensure its cost competitiveness, Ariane Group, the industrial prime contractor for Ariane, has totally revamped its industrial organization and added innovative new processes, such as 3D printing. The space transport industry is undergoing a deep transformation, which means that Ariane partners are already thinking about the post-Ariane 6 era, with a project called Ariane Next. Ariane Group is already working on a new rocket engine, dubbed Prometheus. It will be reusable and burn methane, while also significantly lowering production costs. At the same time, two reusable launch vehicle demonstrators, Callisto and Themis, will be undergoing initial tests in the coming years. 40 years on, Arianespace is more than ever a key to European space strategy. We continue to deliver independent access to space for European agencies and governments, while also providing satellite operators from around the world with proven launch service excellence.
So, as promised, we're going to go back live to Kourou, to Mission Control, to speak to Arianespace CEO Stéphane Israël. Good evening again, Stéphane. Good morning for us. So good to see you again. So we just witnessed a few minutes ago 2 separations for the 7 main deck passengers. With this launch, Arianespace will have reached the 700 satellite mark. Is that right? It's another first tonight?
Yes, it is another first. So now we are going beyond these 700 satellites deployed by Arianespace since its foundation. So it is also another premiere of tonight. It's right.
And I'm sure it's an opportunity for you as well to send a message to all the partners you've been working so hard with on this particular mission.
Yes, I want really to start by thanking our customers for this flight. So now we have had a success for the 7 first satellites. We need to wait a little bit for the 46 which are coming, and you know it will be very exciting because we will have 26 injections to separate them with just a few seconds back to back, so it will be very exciting. It will be in a few minutes. But I want to thank our customers. They are coming from, as we have said, 13 different countries, and we have 21 customers, so really a big thank for all of them. And for sure, I want to thank our partners. This success tonight is a success of a team. It's a European team. Our prime contractor is Avio, based in Colleferro in Italy. We have the support of ESA for this mission, for the European Commission as well. So tonight, it is really the success of Europe, and I want to thank all our partners, and I shall not forget the Arianespace team who has made a terrific job tonight as well.
And of course, as you were saying, the mission is not yet over, so we're going to be able to follow the rest of the mission on social media, right?
Yes, so you can follow it on social media, you can follow it on Arianespace Twitter, and we will communicate as soon as the mission will be over, which will be now in a few minutes.
And when can we expect you to see you again, either in Kourou or here in Paris for the next mission?
Yes, so we will be back in Guiana, in French Guiana, mid-October. It will be the 16th of October. It will be a launch with Soyuz, and I think it's also a great symbol of our family of launchers. We have just done Ariane mid of August, and now we are with Vega tonight, and next month it will be the turn of Soyuz. We have a great family of launchers, and they will deliver for all our customers.
Well, thank you very much. We wish you good luck for the end of the mission in Kourou. We'll let you get back to work. Thank you for joining us again, Stéphane Israël, CEO of Arianespace.
Thank you, Liz. Thank you.
Thanks a lot. So, Luce, mid-October, the next mission that you're already working on, obviously.
Yes, in 6 weeks from now already. I hardly dare to speak about this older brother of Vega today, because I think that the mission is ongoing, and it will be such a great relief at the end of this Vega mission. And I think that all the teams will enjoy and start to enjoy and celebrate this success. But it's true that at Arianespace and with our Russian partners and with CNES teams in French Guiana, we have started we have started the operations, and we have started to work to prepare this Soyuz launch in 6 weeks from now.
So we hope to see you either here in Paris or in Kourou in 6 weeks' time. As we were saying, it is getting quite late, or rather early here in Paris, so we'll be ending the webcast shortly. But of course, you can follow our social media team. We'll be holding you by the hand and taking you through right to the end of this mission. And Alexandre is going to take us through the main stages that we'll be able to follow as well. Thank you, Alexandre.
Yes, so it's important to note that the third Avon boost occurs before the loss of inertia ground station, so everything goes nominally. So customer timeline will end by releasing the 46 additional passengers, so the 46 CubeSat, 15 kilometers higher, after a very small two short boost with the AVUM, and after that, between these two short AVUM boosts, you will have a long ballistic phase. So it's important to note that a dedicated sequencer is on board, and will send the separation orders within 160-second duration for the 46 CubeSats. And all the sequence order and separation direction, of course, were optimized to guarantee for each customer safe condition at injection. It is not, I recall, it's not so easy for 46 CubeSats within a short duration below 200 seconds.
Well, thank you very much for those explanations. This should be happening in a few dozens of minutes from now.
Yeah.
And of course, we'd like to say a very big thank you to the teams both here in Paris and of course the teams in Kourou that have made it possible to bring you this live webcast. A big thank you as well to our interpreters who've brought you the entire webcast in real time in French, Marc Fermin and Alexandre Carayon. So thank you very much, Alexandre, for being at our side all evening and taking us through all the key moments.
Thank you for this opportunity. It was really a pleasure to be here this morning.
Thanks a lot. And Luce, thank you very much. We hope to see you again sort of in 6 weeks' time then.
Thanks a lot to you, Lise. Yes.
The next launch. So a big thank you to everyone this evening, and please stay connected on social media. Stay with us, and we'll see you again very soon. We're going to leave you now with some beautiful pictures of replay of tonight's launch, and we'll see you back here very soon.
Allumage et décollage.